Welcome to the Module 1 and to the first video, Introduction to Raspberry Pi. Since we will be working with the Raspberry Pi, we have to get familiar with it. That's what we will do in the first video. The Raspberry Pi is a credit card-sized single-board computer developed by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools. The Raspberry Pi is a complete computer that runs a Linux operating system. It can be used for programming, writing, or painting, but it also has an input and output port that allows it to monitor and control the environment. For example, to read temperature or humidity, and switch a light or move a motor. It is an amazing device that can be used for the IoT for just $35. Several generations of Raspberry Pis have been released. The first generation, the Raspberry Pi 1, was released in February 2012. The Raspberry Pi 2 was released in February 2015 and Raspberry 3 in February 2016. These boards are priced $35. A simpler model was released in November 2015, the Raspberry Pi Zero, with a smaller size and limited input-output, but just $5. We will be using the Raspberry 3 for the course, but you can also use the Raspberry Pi 2 in case you have one in most of our lessons. Let's identify the parts of the Raspberry Pi 3. Over here we have the brain of the board, the Broadcom system on chip, including a 64-bit processor with 4 cores, ARM Cortex running at 1.2 MHz. And a graphics processor. It is linked to a 1 GB memory module on the rear of the board. Here we have 4 USB 2.0 ports and Ethernet port. It is important to mention that all USB and Ethernet ports share the same USB channel, acting as USB to Ethernet adapter and USB hub. This could be important if the USB consumption is too high. Some of the devices may not work properly. On the bottom we have a jack, stereo audio, and composite video, a camera connector, this is for the Raspberry Pi camera, and HDMI connector to connect to a monitor or a TV. We have the power supply, 5 volts USB connector for powering, and here we have a DSI connector, a display serial interface to connect a screen. On the top we find a very important part. This is the GPIO, general purpose input-output. This allows to connect digital sensors and actuators, and we will cover it in the third lesson. The Raspberry Pi 3 features the same 40-pin header as all the previous Raspberry Pis. Another very important feature is that the Raspberry 3 has built-in Wi-Fi and Bluetooth for Bluetooth Low Energy. There is no need to connect an external antenna to the Raspberry Pi 3. Its radios are connected to this chip antenna soldered directly to the board. We have here the antenna. Despite its small size, this antenna should be more than capable of picking up Wi-Fi and Bluetooth signals, even through walls. On the back side, we find the communication chip, the RAM memory chip, and the SD card slot. The Raspberry uses a micro SD card as hard drive. We recommend to use SD cards of at least 16 gigabytes. Next thing we are going to do is to switch it on. For that, we need to connect the Raspberry to a screen through a HDMI cable. We have to connect a mouse and a keyboard, the power cable, and the SD card. Make sure you have all the necessary equipment. But we need to put something on the SD card. We need an operating system. Let's see how can we get one. First of all, we need an SD card of at least 8 gigabytes, preferably 16 gigabytes, as we said before, to install the OS. Once we get it, we go to this website, the Raspberry Pi Foundation web, to download the operating system. Okay, so we go to this web address, raspberry.org. That is the main web page of the Raspberry Pi Foundation. We click on downloads, and here we find we can download different operating systems. For example, Ubuntu Mate, or even Windows 10, a special version of Windows that runs on the Raspberry Pi. We will be using this Raspbian operating system. There is also a tool called Noobs that allows you to install different operating systems in a very easy way. But since we will be using Raspbian, we can download it directly. We click on it, we go to Raspbian GC with Pixel, and we click on the download zip. Once the file is downloaded, we can install it in our SD card. Okay. For the installation, we can go to this guide where we have different tools for different operating systems, or we can go to this etcher.io web where we can download a software for every operating system. So you can choose here which operating system do you want it for, Mac, Linux, or Windows. Once the file is downloaded, you select the image is the one that you have just downloaded. Select the SD card, the drive where you want it, and then click flash, and the image will be transferred to your SD card. When the Raspberry Pi begins to receive power, the red LED marked PWR will light. The green LED marked OK or ACK in later versions will blink in an irregular pattern to show whenever the Pi reads from the SD card. Please note that the BIOS for the Pi is stored on the SD card, so if booting is unsuccessful, the Pi will show nothing on screen. If you have trouble getting your Pi to boot, read the guide to boot problems from the Raspberry Pi website. If all goes well and the OS boots successfully, Raspbian starts by showing a long scrolling text that tells you exactly what the Pi is doing to get ready to work. The first time takes longer to start. After that, the graphical interface loads and you have a desktop-like OS running, like this one. In previous versions of Raspbian, the booting up finishes with a loading screen, and you needed to expand the file system, but this is already done in the latest version of Raspbian GC with Pixel. By the way, in case you need, let me see, the username is Pi and the password is Raspberry to login. Okay. Next thing, to configure the Raspberry, open a terminal window and write raspi config. Sudo raspi config, and this takes you to the configuration screen. You can expand the file system if you need it. You can change the user and password. You can set up the language on regional setup, enable the camera, and then in advanced options you can activate, enable or disable some peripherals. Okay. Finally, you can also connect to different Wi-Fi networks to be able to connect to the internet. Then you are ready for the next lesson. Experiment, explore, and have fun. Okay, so that's all. In this video you have seen what is a Raspberry Pi and its different parts and connectors. We have downloaded the operating system and installed it in the SD card. And finally, we have set it up, we have switched it on and configured it for the first use. Now you are able to do smart things for the IoT. See you in the next lesson.